So the final is coming a week from today, next Tuesday. So it's a good idea to start to talk about it a little by little, right? So next Tuesday. And let's start with the homework part that will be due for that day. So since the midterm exam, we looked at chapter 4. So we did section 4.3 and 4.4. So that was from chapter 4. Then we moved to chapter 5 and we looked at 5, 2, and 3. Right, 5 will be better. And we also did 5.5 and 5.6, right? So we had 4 sections in chapter 5. And then we also looked at chapter 6. And in chapter 6, we looked at a couple of sections, right? We looked at 6.2 and 6.3. So those are from chapter 6. And we also looked at a couple of sections in chapter 7, also section 3 and then section 4. So 7.3 and 7.4. So those sections that I will hope to get from you by the Tuesday next week, that'd be ideal. So you practice before the final exam, do some problems, and then send me all of your work. And I guess today we'll concentrate on what be on the final exam. And I emailed you a practice exercise here that I guess, going to do right now. And analogously to the midterm exam, this is going to be a 2-question little test. 2 questions is not a big test, it's a little test. But you will have plenty of time for it. So I'm gonna email it to you first thing in the morning, and we'll wait to get your work back same day, sometime in the afternoon or so. So what I'll do is utilize last digits of student ID and the very last digit here, like 6 that I created. If you would like me to use any other digit, just let me know which digit you need. Good morning. You need me to use, so I will use other digit than 6 for the exercise in here. So this problem is talking about the TV show that has a rating of 7.8%. So that's a P, right? Percent. That's the only letter we use for percent, P, which is 0.078. Yes, we're gonna have a final exam here, and we're gonna need to turn in homework. So those are 2 things. So I know some people miss more if they didn't turn in the any homework at all, then well, then it's gonna be missing more than that. But if you turn in your homework already for the midterm, and if you also going to take the final and send it to me, then I didn't understand the question. So just let me know what you mean. If you can turn in any extra work, yes, of course. So if you have any extra work you've done, turn it in. So let us do the problem, and then we can discuss. So you can turn it in. So turn in all work you can turn it. I will gladly accept it. And I keep telling it every class meeting, right? So turn in your work. If you miss something, turn it in. Check your grade. If you don't like your grade, do some work that you're missing, turn it in. If you already turned in everything, you still don't like your grade, well, do the extra credit. So very simple, just extra credit problems. So we'll discuss all that. So I guess you wanna not to use any last digits, but 6 for this exercise. So, okay, I will use digit of 6. And now instead of B, I'm gonna just use 6. Sample size is 100. So if B is 6, then B plus 1 will be 6 plus 1, which is 7, right? So we need to find the probability that out of this 100 people, at least 7. So probability that at least 7 means X is greater than or equal to, right? 7. So X is greater than or equal to 7. So that's a question that we have to work out. This question, by the way, is coming from section 5.6. That's where this exercise is from. So this is so-called continuity correction type of a story. So we need to, well, do the continuity correction to find the probability. We used to put that 7 in the middle, the one before, which is 6, and the one after, which is 8, and then make a picture of what is going on, such as X is greater than or equal to 7. So equal means we include 7. Greater means we go to the right. So we need to know the border value of this region with increment 0.5, right? And that's in between of 6 and 7, so that's 6.5. That's the probability I need to find. So X is greater than or equal to 6.5. So that's a extra thing that section 5.6 gave us. And then we were just doing the problems with all of this process of normal distribution story. So I have that region here that will be going all the way to the right from 6.5. And goal was to always do the same thing, convert to the z-scores. So on the test, you're gonna use exact same formulas, exact same everything. So you're gonna need to convert the 6.5 to some z-score. And we're going to use the formula for z-score for that matter, which is X minus mean, which is NP, divided by a standard deviation, which is a square root from NPQ. So that was the way to go whenever you worked on the normal approximation. So that was mean here, and that's a formula for standard deviation. And we need to utilize the calculator for it and also find Q, a friend of P, which is 1 minus P. Always like that, right? So we go with 1 minus 0.078 and 0.922 is what I'm going to use instead of Q. So let's use it. The value of X that we just found is 6.5. Subtract a product of 100, which is sample size, with 6.5. That's our P, right? So we multiply these guys. And in denominator, we have a square root to extract from, again, 100, and again, multiplied by that number P, which is, oh, I wasn't careful. I need to wake up, I guess. It's not 6.5, it's 0.78, right, instead of P. So you should be careful, put them in correctly. 0.78. And the Q will be also decimal, which is 922, right? The one we just produced. So this is what I need to carefully enter into my calculator, and to carefully means you want to make sure that your numerator is inside the parentheses, right? So that's how we get that z-score, because once we get a z-score, we will get ourselves a nice answer. So let's do this. So it looks like I need to, a little bit of mess here. Maybe I can clean this mess a little bit so we can better see what is happening when I enter this. Okay. So numerator is in the parentheses. It's 6.5 minus. So enter this, redo this problem. Don't just look at how I solve it and say it's okay, and then start wondering what's going on. Do this problem tonight or tomorrow, and then when we meet again on Thursday, that'd be our last class before the final, let me know how you did it, because if you can't, we'll work on it together, because the point is to make sure that you can do this. That's the main thing, that you can do this, not I or your tutor, but that you can do this, right? So that's why I'm doing it right now. So I'll give you time to look at this solution and to try to do this again. Same thing on your own, just put your own digit of student ID to make sure that you can make it, right? That's the whole point. So negative 0.49, right? That's the one that I get because I need to round always to hundreds, right? So round to hundreds, go to the tables, and get the answer from the tables. So it looks like in the tables, I need that negative 0.49. Maybe I can try to bring this down a little bit so we can see that row that we really need, negative 0.4. Okay, so hopefully it's good enough. So z-score happened to be negative, so minus 0.4 is here, the row. Then 0.9 is very last column. So they meet right here at this value, and this value is 3121, right? Okay, whatever it is, it's there, 0.3121 area from the left. It's always area from the left, and that's fine, right? Because we can always get the area from the other side if we subtract it from number 1. So 1 minus this 0.3121, and this is going to be 0.68, and then 79. So I'm going to put same wording in the exercise, just a little different numbers. So you're going to see some TV shows, so it'd be a familiar exercise. So I hope when you see same wording and the same exercise, and you already know the plan how to do it with a little different numbers, then it shouldn't be giving anybody a panic, especially if you practice to redo this before, maybe before Thursday, and then next Tuesday is our final, so maybe before next Tuesday, sometime over weekend or on Monday. So this way, I hope you will feel comfortable with this, because this process is pretty much all we did after the midterm, and more than only half of exercises, right? We had these tables in use, we had the z-score calculated, and these formulas we utilized. So I hope this be something that will make you feel comfortable. So that's why I put the exercise that deals with this z-score stuff. And guess what? Another exercise for the final exam will also deal with a z-score process, but it will come from chapter 7. It will come from section 7.4. So the same type of story, but will come from section 7.4 with a little bit different structure. In 7.4, we used to test claims, right? So in section 7.4, so let me go to page, it's like 430, looks like. Let me do a problem that does the test of the claim here. So how about standard exercise here? Let's say number 23. And by the way, this is also kind of exercise from homework, right? So they here talking about some nice story, but let me see where the numbers are. Oh, that's beyond the basic. No wonder it looks kind of odd. No, I will ask you some standard kind of question. So let's try one. Smoking and college education, for example. Here's the good exercise, and that's related to a real life. I'm not sure, did I do this exercise? It sounds a little bit familiar. How many people smoke when they're in college? Maybe I can try something else, maybe like 14. Testing the nicotine patches. Let's do that. Do they help those patches against smoking or not really? Let's find out. So they want to get this 39 people that were smoking, 32 were not smoking. And at the significance level, majority, oh, I think I'm in the wrong section, because I think I'm in the section 7.3, yeah, 7.4, I think I just need to be a little bit more careful. In 7.4, so let me find the problem in 7.4. So, because they put on the final section a problem from 7.4. So what we didn't do from 7.4. Analysis of last digits. So that I think is very exciting question. The reason it is very exciting, because you can check and see if some is just made up, someone made up the data for whatever information they're supposed to provide people with. I say, how is it possible? Well, let's see how it is possible. So notice that they looking at the last digits, and they say that it should be a 4.5 for the mean, and standard deviation 2.87. So standard deviation is 2.87, and the average on the digits in between 0 and 9, it's in the middle, right? So 0, 9 average is 4.5, or next 1 and 8, you add them, you get 9 over 2 is again 4.5. So the average digit should be 4.5. So what they do here is they say 73 home runs. So number of home runs provided was 73. Right? So again, I'm doing exercise number 14. So out of these home runs, for the population with a mean 4.5, the test that claimed they came from population with mean of 4.5. So in the claim, we say that population mean is 4.5. Notice I didn't put mean very good way. I need to put it on the same line with claim to make sure I know for sure where my claim is, because I put it lower, then I may forget and not be sure if that's H0 or H1. So it looks like there's three numbers that we had so far is here. So I just wrote them down. And once I hear word claim, I know I need to put H1 or H0. So what would you use, H1 or H0 for this one? I use H index 0, right? Because it has equal sign. So H1 never ever has equal. So it must be not equal. So it must be mean is not equal to 4.5. They're always opposite. So one is equal, the other is not equal. And not equal, we already know it's going to be two-sided hypothesis because it's either on the left side of 4.5 or it is on the right side of 4.5. So we have the two sides for this. And right away, I can picture this two-sided hypothesis. So I'm going to put this right end and the left end. And actually, there is a number called significance of 0.05. 0.05 that is going to be split into two equal pieces because they're always equal, because we always deal with normal distribution. It's symmetric from the center. So it's 2.5 for each little tail. So we call these as areas that correspond to H index 1. So this piece, as well as that piece, right? And the middle part is always H index 0. So H0 is always big. And now I need to know this cutoff z-scores. Notice they must be symmetric. One of them is with minus sign, and the one on the other side is with a plus sign. And to find them, I will use this little tail area 0.025. So back to the tables, 0.025, I have to find in my tables, and it is one of our favorite numbers, right? We encountered it already a number of times. So it is right there, 0.25, did you see it? So we have a row with negative 1.9 and a column with 0.06. When I compose these two, it's a negative 196. And the other side then will be positive 196. So I got the z-scores. And now I can calculate z-score for this particular sample. So the z-score formula is x minus mean divided by standard deviation over square root of n. So that's the one that we used for normal distribution. That's z-score formula. And you will need to use it also for the final exam, because I'm doing a problem of the same kind that you will encounter on the final exam. So it looks like I have all the data here so far, except for one number. I have mu, I have n, I have sigma, and there's also supposed to be a value of x. So where is the value of x? Well, in this exercise, they decided for some reason not to write it here, but they put it there. So let me clear this, it's getting too messy. So you see where the value of x is, they put it here, they say it's in some kind of display. Well, on a test, you're not going to have it in a display. I just tell you clearly that it is 1.753. So it'll be here 1.753, whatever it is. We just plug this in a calculator, right? So mean was 4.5. That's always in the claim, mean for population. Standard deviation is 2.87. And this is divided by a square root extracted from the sample size of 73. So what is going on here? Well, some player gave a data in his resume that his average is number 1.753, whatever it is. And what you do is you check and see if that's realistic or if it's made up. If it's made up, you're probably not going to consider that resume, right? But if it's realistic, well, then maybe you will try to work with this person. So let us calculate and see if this makes sense, because it seems that it's a little bit off, right? If those numbers are not made up, the last digits should not have average of 1 point something. It should be 4 or somewhere in that area. And that's why the suspicion came in. And that's why we actually doing this exercise. So put by 3 minus 4.5. And this is in the parentheses, and then it's divided by, now again, parentheses, right? So I would say it's a good idea to you that you redo the same calculation on your own. Just get your favorite calculator or use one that I use right now, because this way you're going to not make mistake for sure. So here's my z-score, which is pretty low, right? So if z-score is a negative 8.17 ... then this z-score is going to hit the area called H index 1, right? Because it's all the way here on the left side, H1. So you're going to say yes to H1, and you're going to say no to H0. So what does this mean? Well, it means that this data does not match the general population of data that has average of 4.5. So it's not the one that we accept as correct. We say, no, it is not coming from population. So we say that player probably made up the data, and that's why it's not really what is realistic. But on the test, all I need to see either yes to the claim or no to the claim. And it wouldn't really matter if somebody believes in the claim or does not. The point is to either accept that claim or do not accept it, just like I did in this exercise. So I rejected that particular claim. So that's all you need for the exam that we're going to have a week from today. That again will be sent to you by email, analogously to this practice test. I hope you all received this practice test for the final. So look at it again. Try to do it before Thursday, because on Thursday I plan to answer your questions. So I guess I already gave you everything you need for the final to practice on it. And all I'll do is just answer your questions on Thursday if you have any. So that's the plan for the next time. So I don't give a quiz today. It's already plenty of quizzes we had. So no